In this special program, we track the rise of the superbug. From a growing caseload of untreatable diseases in India to Kenya's chicken farms, where antibiotics are part of the daily diet and the problem. We're inside a lab in the UK, where the DNA of superbugs are sequenced and tracked. We take a look at a tiny device developed in the US that could save millions of lives. Hello and welcome to this special program looking at the growing global problem of drug-resistant bacteria or superbugs. Today, superbugs kill more than 100,000, perhaps as many as 250,000 people around the world each year. And that figure, without action, could grow to as many as 10 million a year by 2050. That's more than are killed by cancer. In a recent survey done for the UK government, that's expected to cost the world's economies around $100 trillion over the next 35 years. Well, in a moment we'll look at how that drug resistance develops in bacteria and why the drugs don't work. But first, Nidhi Dutt visits a clinic in the outskirts of the Indian capital, New Delhi, where this global health threat is playing out.
He's just 14 months old. But for months, Arun Shibbu has been ill. He had typhoid and first saw Dr. Neetu Talwar in January. It took 2 courses of treatment, but now finally he has the all clear.
Since the time we have started our services, almost most of the cases that we have had are drug-resistant cases. Most of them, almost all of them have been multi-drug resistant. So it is a problem.
For adults too, getting the right medical treatment is a growing challenge.
I had a fever for a long time and I couldn't eat. I took lots of medicine and my neighbour even took me to get an X-ray. I got medicines from one doctor and then another and then another. When the first treatment didn't work, I went to another for help, but then the second doctor's treatment didn't help either.
It was only when she visited a clinic close to her home that Manorama was found to have drug-resistant tuberculosis. Dr. Shelly Batra has spent the last 20 years treating difficult TB cases and says more and more drugs are becoming ineffective against the disease. She partly blames unqualified health providers.
There are informal providers all around. Some of them are not qualified to write a prescription. So when they write incomplete prescriptions, that is one way patients get drug resistance. So training and upgrading the skills of informal providers is very much required if we want to prevent this disease.
Once a drug-resistant strain of bacteria like typhoid takes hold, it is passed on to others in a community through contaminated water and waste. Sanitation is a daily challenge for people in communities like this, and drug-resistant illnesses are a growing threat. Where the government has failed to fix the problem at its source, health workers have tried to compensate by treating the spread of illnesses with a host of medicines. While ad hoc treatment has done little to contain harmful bacteria, it's raised important questions about the capacity of India's healthcare system to deal with diseases that affect millions of people.
Drug resistance is not just going to lead to a huge number of deaths. Millions of people are going to die due to causes that could have been treated.
Doctors around the world have long been aware of the potential threat of drug resistance. But now, with the number of cases on the rise, that threat is real. They back calls for global action to help stop superbugs and hope it will be enough and won't come too late to protect the health of the next generation.
But when a patient arrives at a hospital like Hamad General Hospital here in Qatar, and doctors suspect that they have an illness which is drug resistant. Well, samples are brought to a laboratory like this one. It's here that samples are tested against a variety of antibiotics to see if indeed they are drug resistant and to see which antibiotic is the most effective. Overseeing the lab is Dr. Ibrahim. How do you go about testing these antibiotics?
Yes, we have here a very highly quality scheme and program for identification and performing antimicrobial sensitivity testing. This is a disc which is impregnated with antimicrobial, and we look for the zone of inhibition.
So essentially on this petri dish you have a bacteria living across the
We
whole
have
dish,
a living bacteria.
and then these spots are where you've put antibiotics.
Exactly.
And you can see which ones have killed the bacteria off and which have been less effective.
Exactly. We have a test here called the E-test. This is a more precise test. It tells us how far is sensitive or how far is resistant.
We've seen the impact superbugs have on human health, but in animal health it's also a massive issue. In the United States, 80% of the antibiotics sold each year are fed to animals. One survey suggested 63,000 tons of antibiotics are fed to chickens, pigs and cattle each year. As a result, superbugs are increasing in animal populations, and with it, the risk it will spread to human populations. It's a trend that's being seen in the developing world as well, where meat demand is growing fast. Malcolm Webb visited a chicken farm on the outskirts of Nairobi in Kenya, where antibiotics are part of the daily diet.
Business is booming for Daniel Kariuki. His chicken farm's near Kenya's capital, Nairobi. And key to his success are antibiotics. He puts them in their drinking water every day. But the bacteria often become tough and resistant, and so then he changes to another drug.
There are times that disease becomes persistent. You'll find that you have given the treatment as required, but maybe 50% of the birds have not been cured. So what happens, you have to change the type that you are using, because that means it's not effective.
Can I get a quarter chicken and
Just a few kilometres away in the city,
In fact, let's make it a half chicken and chips.
it's takeaways like this where the chickens end up.
Every day, all across the developing world, more and more people are eating food like this, and not only chicken, but also all other kinds of meat and animal products. Growing populations mean there's more mouths to feed, and growing economies mean more and more people can afford food like this. In the developed world, most countries have already reached their maximum meat consumption, but in the world's giant emerging economies like China and Brazil, it's been growing for decades and it's expected to grow for decades to come.
And more meat means more antibiotics. And that means more bacteria will become resistant. Scientists say common infections that are easily treated now, in the future will become untreatable and fatal. And not just in animals, but in people too. Here at the headquarters of the International Livestock Research Institute, scientists say they've detected a rapid increase in bacterial resistance in developing countries. Biologist Timothy Robinson just published a paper on it.
We're just starting now to gather the magnitude of the problem of antimicrobial resistance developing. And it's a problem that affects absolutely everybody in the world. Everybody is dependent on antimicrobials for their public health and for their livestock's health as well. And so it's a massive problem that's just going to get worse and worse unless we start to deal with it now.
But farmers like Daniel can't really deal with this massive problem by themselves. Keeping his chickens healthy using antibiotics is what keeps his family fed and his children in school. In developed countries, farmers now use less of the drugs because of regulation and public pressure. But farmers in the developing world are going to need help to do the same.
Let's take a look now at how drug resistance develops. Take a bacteria like E. coli. We all have E. coli in our gut, but some strains of it can cause diarrhea, kidney failure, even death. Now, traditionally, you would have treated that with penicillin, one of the first antibiotics discovered. Thing is, penicillin causes the cell membranes to rupture, job done. Now the problem arises when patients don't take the full course of their antibiotics, or perhaps the antibiotics are of poor quality. This gives the bacteria the chance to mutate and develop resistance to the drug. If this happens, the drugs don't work, and the drug-resistant strain of bacteria can fast become dominant. Last year, the World Health Organization said that antimicrobial resistance has reached all parts of the globe. It's a threat to public health everywhere, and action is required. Well, one of those also calling for action is Dr. Sally Davies. She's England's Chief Medical Officer. Now, Sally, you've described the threat of antimicrobial resistance as being as real as terrorism. Why did you say that?
Well, if you think about it, terrorists aim to kill people, but actually don't kill very many. Whereas AMR, that's the bugs aiming to live, and as a result, when they infect people, they kill the people, and they're having great success. Look at the data. In Europe, about 25,000 deaths a year at a conservative estimate. That's more than road traffic accidents, it's just edging ahead. Similar sorts of numbers in the States, but I think it's over in the Far East that it's even more worrying when you hear about one child under the age of 5 dying every 5 minutes of AMR. That is to say, of infections that we cannot treat with our present antibiotics because the bacteria have grown wise to the antibiotics and are not killed by them.
It's been reported that half the antibiotics prescribed in the US in 2010 were unnecessary. They weren't actually necessary for the patient. Surely doctors need to take some responsibility for prescribing these?
It's very difficult at the time of prescribing to know what is necessary and what isn't. We don't have rapid diagnostics, and that's where, in fact, quick whole genome scanning might help. But we need rapid diagnostics. Until we have them, what we know is people think the patient has an infection, the patient thinks they have an infection, so you have to use antibiotics blind, that is to say informed guesswork, until you have the results of cultures. And then you get bad behaviour by patients and clinical staff where the patient says, I've got a sore throat, I must have antibiotics, it always goes to my chest, I must have antibiotics. And the doctor hasn't got the time or the energy to debate this, argue it, and doesn't want to take the minuscule risk that it might not be viral and gives in. I can understand all sides, but there is far too much use of antibiotics. If you look at prescribing in Britain, it's the same in the States, so I guess it is all over the world, you can see that some areas prescribe double the number of antibiotics as other areas, so there must be overprescribing.
We've seen how devastating the effects of drug resistance can be in a place like India, poor communities. Do you think this poses more of a threat to the underdeveloped world and countries without strong health systems?
I am very worried about the developing world. If you look at the work and the modelling that has been done for the Prime Minister's independent review on antimicrobial resistance, led by the economist Jim O'Neill, you can see that they reckon that if we don't turn the tide on this, in 2050 there will be 10 million deaths a year, more than we have dying at the moment of cancer every year, and that will be predominantly in the developing world. India, China, they will all suffer. And it is to do with, in part, their health systems. As you develop health systems, you can have stronger mechanisms for ensuring that the drugs are good quality drugs, that they're only used when prescribed, that they're backed up by laboratory diagnosis, and that they are taken for a full course. Many people in the developed world will do that, but in the developing world they'll go and buy some drugs over the counter, perhaps buy one day's amount, and then if they feel better, they stop. Other people will buy a handful and they'll share them out around the family. And that's assuming they're good drugs rather than counterfeit or falsified, which adds to the problem.
We'll hear more from Dr. Sally Davies in a moment, but first let's take a look at some of the work being done to better understand how superbugs evolve and how they spread around the world. The Wellcome Trust Sanger Institute near Cambridge is a world leader at this and showed Nadine Barber some of its recent research.
You might not realise it, but you're looking at a medical revolution. When it comes to diseases, researchers here at the Wellcome Trust Sanger Institute aren't just interested in what strain of a bacterium is the cause. They want to know the entire DNA of the bug. They call it whole genome sequencing, and these machines are at the heart of it. Well, they may look like high-tech refrigerators, but these sequencers are at the heart of the science that researchers hope will one day allow them to track diseases around the world in real time. Julian Parkhill heads a team that's developing ways of tracking a whole range of so-called superbugs which have become resistant to antibiotics. He likens the approach to creating a family tree of the bacteria.
So if I take the bacterium from you and the bacterium from me, and I take the whole genome sequence of both of them, I can say how closely related they are, how long ago they shared a common ancestor, and therefore how likely it is that you gave that bacterium to me or I gave it to you.
Last year, when scientists here were analysing a previous outbreak of the MRSA bug in a local hospital, medics called to say a baby on a ward now had the infection.
So we put the sequence, we put the DNA from this organism directly on the sequencing machines, and we identified that it was part of that outbreak. There had been a gap of 2 months with no babies on the ward having MRSA since the outbreak that we were studying retrospectively. And that gap meant that it couldn't be continuous transmission between babies on the ward, and therefore there was likely to be the involvement of a healthcare worker in reintroducing that strain into the ward.
Soon, thanks to blood samples from all the hospital staff, they identified the worker who'd reinfected the baby unit. That person was quickly treated and the outbreak was contained. In another part of the Sanger Institute, they're working on a mass killer, malaria.
They send us samples here which have been extracted, which have been taken from a patient's arm, blood that's been taken from infected blood.
Researchers are busy analysing how the plasmodium parasites that cause the illness in humans are becoming resistant to anti-malarial drugs. But they're also trying to discover how the mosquitoes which spread the parasites in the first place become resistant to insecticides.
To control malaria, you want to do two things. You want to get rid of the parasites in people who've got parasites, particularly if they're ill, and you want to stop the mosquitoes transmitting malaria. And there are various strategies for doing that, such as getting people to sleep under insecticide-treated bed nets. We have to be concerned both about whether we've got effective treatment for parasites and whether the bugs are resistant to that. Equally, we have to have effective insecticides to get rid of the mosquitoes, and we are worried about insecticide resistance in the mosquitoes.
Malaria affects hundreds of millions of people every year, and it's a major cause of death among children in parts of Africa. Experts are worried that resistance to the frontline treatment artemisinin, which has been increasing in Southeast Asia, could be repeated in sub-Saharan nations.
The death rate from malaria is very high already. Despite the availability of effective drugs, it's already high. So if the drugs are not working and there is no replacement drug handy, then it's going to be a disaster.
But that disaster need never happen as long as the world can share the lessons from the genetic mutations that they're finding out about here.
One issue that experts say is compounding the problem is we're not coming up with enough new drugs. In fact, the last antibiotic to come to market was almost 30 years ago. It's simply too expensive and too slow for the major pharmaceutical companies to make the investment. But that may be about to change. From San Francisco, Jake Ward takes a look at some of the research being done to develop new drugs in the United States.
I'm going to grab your temperature.
The United States has a bug problem. Multi-drug resistant bacteria, superbugs that have learned to shrug off the antibiotics we normally use to kill them, plague the health system here. According to the Centers for Disease Control, these bugs infect 2 million people a year in the United States. 23,000 of them die.
In our society, people move between the skilled nursing facilities and their outpatient care doctors and the acute care and around, and so these organisms can get spread. These organisms can live on the skin, and they can live on the surfaces of a desk or a bed or a stethoscope.
The frontline solution is cleanliness, constantly washing hands in hospital facilities, but also isolating infected patients. At one of Chicago's largest hospitals, Dr. William Trick is trying to automate a process of identifying the bacteria patients carry and quickly communicating that information to the entire healthcare system.
We can then tell the hospital, this is a patient known to have this highly resistant bacteria, and they can immediately and appropriately put them on the right precautions to prevent spread to other patients.
The trouble is that it takes days to identify specifics about the resistant bacteria. Dr. Lee Riley has just received a multi-million-dollar grant to develop a process that would identify the right drugs to fight bacteria in minutes.
If you can determine what the drug susceptibility of that organism before the patient leaves your office, then you can give the right drug, and then you don't have to worry about creating drug resistance.
But Dr. Riley says that in many cases, maybe even in most cases, we are not infected in the hospital. Instead, the bacteria enters our bloodstream during our day-to-day lives.
We think that these infections are probably acquired through contaminated food products, being exposed to a variety of food products that may be contaminated with bacterial agents that carry drug resistance genes.
Here in the U.S. and around the world, companies simply are not making new antibiotics. It's just too expensive and too hard. In part, that's because they've pretty much tapped out the microorganisms that can be easily cultivated in a lab setting. The truth is that there are enough microorganisms in this handful of dirt to pursue countless lines of new possible antibiotics. But it's only out here in nature that those microorganisms will thrive. As a result, researchers are limited to the tiny number of microorganisms that grow in a petri dish. Microbiologist Slava Epstein realized this was a major problem for researchers.
That gap is humongous, which means a very large amount of microbial diversity on the planet is just not accessible. So this is the entire diversity on the planet. This dot, the red one, is how much of that we have cultivated.
Epstein's team developed a device, the iChip, that can isolate cells in dirt to let them grow the way they do in nature.
It lets nature provide the necessary component for growth, and then the cell grows and forms a colony. And once it forms a colony, we can explore this colony on its ability to produce a new antibiotic.
The hope is that a new crop of antibiotics used on bacteria that have been quickly and specifically identified could slow deadly infections around the world, infections that our food and our hospitals seem to have helped create.
In May, a report prepared for the UK government suggested the creation of a fund that could pay out up to $3 billion to large pharmaceutical companies that develop new antibiotics. Economist Jim O'Neill was the author of that report.
Takes the downside risks away for the pharmaceutical industry to undertake these kind of risks, which from a world I've lived in of risk versus reward, I would have thought that seemed like a pretty important attraction. We're pursuing lots of other important paths, and in particular one that in my growing judgment is perhaps the most important, which is the demand side of the problem, and we all stop wanting to use antibiotics as though they're sweets and put pressure on our food companies to stop using them for feeding animals. So better diagnostics, less, if not no use of antibiotics for fattening up animals, and probably a major education campaign specific to different parts of the world to just let people know that just taking antibiotics isn't necessarily a good thing to do.
Well, I want to come back now to Dr. Sally Davies, England's Chief Medical Officer. Do you think a $3 billion incentive is enough to get the interest of pharmaceutical companies?
Well, I don't know whether that is absolutely the answer. Jim O'Neill, who's been asked to do this work as an independent economist, is going round with his views, discussing with governments to try and get a global view, because if that's the right answer, and it may well be, then we've got to get a lot of governments subscribing to it. But what I do know is the present system's broke. No new antibiotics marketed that were discovered after 1987. We have passed the golden age, and it's a very difficult area. It's difficult science, and the world has disinvested in the scientists who do that sort of work. So either Jim O'Neill's solution or another, I don't mind as long as we get the solution and move forward to start developing and then delivering new drugs.
That's all we have time for in this special program. There's plenty more on superbugs and what's being done to address the global threat on our website at aljazeera.com. Thanks for watching. Goodbye.